So, good afternoon, everybody. Welcome to the distance learning program. And today we are going to talk about open source software, technology, and tools. My name is Prasun Kumar Gupta, and I am with the Geoinformatics department here at the Indian Institute of Remote Sensing. So, what are open source tools? Why are they special? We will see all these aspects in today's session. We all use open source tools, either knowingly or unknowingly. For example, if you have to watch a video file on your computer or on your mobile phone, you would be using something like the VLC player. Or if you're browsing the internet, you would probably be using the Firefox browser. If you are in a university or a college and you're using a learning management system, you're probably using Moodle. And if you are doing some sort of statistical computation, you are probably using the R language. Even the secure framework, the SSL framework that we use for our banking transactions, is also open source. So all these are examples of open source tools and frameworks. So we are all using open source in our daily lives. We just don't know that it is open source. There are different types of operating systems. There are different flavors of Linux, like Ubuntu and Red Hat and so on, which are open source. Over 90% of the websites around the world are hosted on a web server called Apache, which is open source. All the good known programming languages like PHP, Python, MySQL, these are also open source languages. So we are all using open source tools and softwares in our day-to-day lives. Sometimes we just don't know we are using open source. Why open source? Why is it important, or why do we need to know about it? First thing and the biggest thing which attracts people is that it is free. Open source softwares are traditionally said to be free. That is, does not cost you any money. Second, you have the control over the software. Now, what kind of control are we talking about? Now, what is an open source software and how is it different from the opposite, that is a closed source software? Any software for that matter is a program written in some language, let's say C++ or Java or Python. And the program in which it is written is intellectual property. It's the property of the company which is developing it, or it is a property of the developers who are developing it. Some developers choose to monetize it. They choose to sell it to people and make money. That is how software corporations are formed. And there are some people who wish that everybody could use the same software and get benefit out of it. And so these are two kinds of, you could say, thought processes which are there. And in the first thought process, that is to monetize it, they do not give the source code. They compile the file, create a binary executable, and give it to you, such that if you even try to open it, all you see is zeros and ones, and you cannot recreate the original source code back. Whereas in the second case, the source code is available to you. You can easily edit it, you can modify it, you can have control over it. You don't want certain parts of the code to run, or you want to add things to the source code. All that kind of control we are talking about, that kind of control we are talking about with open source software, because you have the source code, the original program in which the software is written. So when I'm talking about VLC being open source or Firefox being open source, you yourself can actually go to their repositories and download the programs which are used to make VLC, to make Firefox, to make Moodle, and so on. So it gives you the flexibility. You can break open the software, look what's happening inside, join them, remove certain pieces, add certain pieces, and so on. Third thing is you have more quality. Now, these open source softwares are generally volunteer driven. So these volunteers are globally, worldwide, and they are looking at the software continuously. So if there are bugs or if there are things which should not be there, they get noticed quickly. Whereas for closed source softwares, which are developed by a company or a team of users, there is a team of testing the software, and it is their job to find out bugs. So they do it like a job and not like a passion. For open source softwares is developed generally by passionate users and contributors who think that they can contribute to this domain and other users can gain out of it. And in most cases, open source is leading the innovation. The open source software is creating better products or newer products with newer features, which then gets emulated, I would say, into closed source softwares. So Wikipedia says that open source has these advantages. It reduces software costs. It increases the security and stability, especially in regard to malware. So for closed source softwares, you don't know what is happening behind the scenes. The software is saying that we are processing something, but instead it could be stealing something from your computer. You do not know. So that is the problem with closed source softwares. You cannot see inside what is happening inside. Whereas for open source softwares, the source code is available. It is open. You know what are the steps which are happening, whether it is doing what it is not supposed to do. That can be caught much quicker as opposed to closed source software. So open source increases security, increases stability, it protects privacy, and gives users control over their software and hardware. So does it mean that free software and open source software are the same things? Well, no, there is a very small difference, and I would like to highlight here that free here does not refer to price. It refers to liberty or independence, you can say. You have, it's equal to free speech and not equal to free lunch. Okay, so here we're talking about free as in free to use for any purpose, free to study the software, how it works, free to give it to your friends and colleagues, free to modify the software and to give or redistribute the copies of these modified versions of the software. So that is what free software in this context means. It doesn't mean software which comes for free and you can download. Obviously, that is there, but the word free is used in the context of freedom or independence. I think they have a different word in some countries. They call it the libre software. Libre, I think, in French means freedom. So my pronunciation may be wrong, but yeah, that is. So that is what is free, what is meant by free and open source software. So in the domain of geoinformatics or GIS, there is another term called FOSS4G. FOSS4G meaning free and open source software for geoinformatics. Okay, so here the number 4 refers to for, and free and open source for geoinformatics. This is a single term which is used for all the open source softwares in the GIS domain. And there are FOSS softwares in almost every branch of GIS softwares. For example, there are free and open source desktop GIS softwares, free and open source spatial extensions to open source database management systems, free and open source web GIS libraries, code libraries, mobile apps, and so on. So there are open source. There's not a single software that we're talking about. We are talking about a suite of softwares, and each of them is specialized to do a certain task. Now, why is it important that we know these softwares? It is important because there is a lot of money in software. There's a lot of money involved in the geospatial industry. Currently, the geospatial industry is valued at $270 billion US. And this brings in a lot of revenue to a lot of different sectors. So about $1.4 trillion the geospatial industry saves businesses each year. $90 billion goes out as wages for people working in the geospatial industry. 1.1 billion hours of travel time is saved per year globally. $0.5 to $2.8 billion of saving from reduced pricing of infrequently bought services and goods. 3.5 billion liters of petrol saved globally. $8 to $22 billion of global cost savings on agricultural irrigation, and $73 billion industry savings, industry value in the US alone. So within the US, they are generating about $100 billion of revenues, and globally around another $200 billion of revenue. So you can imagine the size of business. And within this business, about 75% is dedicated to software and software services. So roughly out of 300 billion, 200 billion US is spent on buying software or buying software services. And this market is growing rapidly at around 15 to 20% compounded annual growth rate. So roughly every 5 years, the number, there's 100% growth. That means within the next 5 years, this is going to become $300 to $600 billion. So there's a lot of money involved, huge money involved. And that is what interests a lot of these companies in making closed source softwares, in making softwares which are kept as closed intellectual property and not given out to users for freedom to modify and redistribute. So this brings us to an important topic, that is licensing of softwares. We know we've all installed some closed source software on our computers sometime, and it would pop up saying, do you accept the terms and conditions? And I'm pretty sure none of us read those, just say agree and go ahead. So that is the case for proprietary softwares. Now there are free software which does not cost any money, it is open for everybody. Does that mean it does not have license? It is not so. It has license, and there is a vast licensing subject semester on licensing of open source software. There are free software domain can be divided into these different parts. The open source software part has softwares which are public domain softwares, where the software is kept in the public domain. Then there are some softwares which are under lax permissive license. There are softwares which have a relatively easier license. Let me explain how it's easier. So before that, let's look at this. Softwares under GPL. GPL stands for General Public License. What is GPL? GPL is the original licensing which the GNU Foundation proposed, and they said that that if you've got a software for free, you must pass it on for free, whether it is whether you spend your time, money, effort in improving it does not matter. If you have got it for free, you must give it out for free. So those are softwares which are released under GPL. Then there are softwares which are under a lesser general public license, or LGPL. That is a permissive license, which says that, okay, you've got a software for free, and you have invested some time, money, effort in making it better. You can sell it for a profit. Okay. So that is also an open source software, but it is under a different licensing regime. Okay. So there are several other licensing terms. The broad categorization is GPL and LGPL. Then there is MIT, BSD, Python, Apache. These are all having their own licensing terms. So yeah, as I told you, GPL is software which cannot be mixed with proprietary software, cannot be sold. It is open forever. And LGPL is software which can be mixed with proprietary softwares. A very classical example in GIS domain is a library called GDAL, GDAL, GDAL. This is a library which is an extensive library, a very big library, code library, to read and write raster and vector data. So it's a C++ library which helps to read and write raster and vector data. Until some versions back, even proprietary softwares were writing their own code to read and write raster and vector data. But then they saw that GDAL is licensed under LGPL, so now they've stopped writing that, and they're instead using the same GDAL library and pasting it on a proprietary software and selling it to consumers for a cost. So that is the primary difference between GPL and LGPL. And as I told you, there are different other licensing regimes. Some allow commercial use, some allow distribution, some allow modification, some allow even patenting, and some allow to apply for, some allow for liabilities or warranties, and so on. So there are n number of combinations based on what you want to, what kind of license you want to put your software under. To help you with that, there is a website called choosealicense.com, and there you can turn these options on and off and select which is the right version which works for you. So whether you want to take any liabilities if your software doesn't work, or whether you want to allow it for commercial use, so on and so forth. So as I told you, in the domain of Phos4G, there are hundreds of softwares. Desktop GIS, there is QGIS and JUMP and ILVIS, MuDig, Saga, And then for expert users, there's GRASS, GIS, and Awesome. Spatial databases, there is MySQL and PostGIS. In code libraries, there is Zital, GeoTools, Proj. Web mapping, there's GeoServer, GeoEXT, OpenLayers. Data visualization, there's GeoDA and GRADS. And spatial cataloging, there is GeoNetwork. So these are just some of the most popular, up-to-date, useful softwares which are in these domains. But apart from that, there are hundreds of other softwares, each specialized to do a certain task. Now, which one should I use? So if you are a beginner or if you are the casual user, you can try starting with JUMP, or you could try with Quantum GIS. Quantum GIS gives you enough power to become even an advanced user. Whereas JUMP doesn't have so many functionalities, it will make you an intermediate user, then you'll have to jump ship and go either to GRASS or Quantum GIS. GRASS is not recommended for beginner users. It is recommended for somebody who has some experience. So for intermediate to advanced users, GRASS is a very good tool. If you want to learn more about these softwares, there is a link called osgeo.org. OSGeo is an organization which looks into funding and taking care of all these different projects like QGIS, GRASS, and so on. They have a page called resources where they have listed different tutorials on how you can use GIS for school education, or an introduction to GIS, or GIS for botany, GIS for archaeology, and so on. So different kinds of resources are available here. You can go to this website and have a look at what things are useful for you. Sometimes people do face some issues installing these or using these. To overcome that, OSGeo has come up with an initiative called live.osgeo or OSGeo Live. This is nothing but a file which you can download from their website, and you can burn it on a flash drive, a pen drive, put it in your system, and boot your system again. You will see a new interface which has a new operating system, and all the GIS softwares are pre-installed. Some also have tutorials and sample dataset on the same virtual machine. So the file that you are burning on your flash drive is a virtual machine. So when you boot it from your pen drive, you are running the operating system from your pen drive. Okay, and this operating system already has all these softwares which are pre-installed. And so that can be a good starting point if you want to explore things. Look at the different softwares. Does it serve your purpose? Is it user friendly? This is a good place to start. You can just download this virtual machine, install VirtualBox or some other software like that, and boot the virtual machine up and have a look at what are the softwares and how does it work for you. Now I'll give you some brief about some of the common softwares. One is QGIS, as I told you. QGIS is a user-friendly open source GIS client where you can visualize, manage, edit, analyze data, and compose printable maps. You can make very nice maps in QGIS. It includes powerful analytical functionality through integration with Saga and GRASS. So what it has done is it has become so popular that it has taken functionalities from other popular softwares also. Powerful softwares like Saga and GRASS, these are also very powerful softwares. So what QGIS is doing, it is borrowing some of the functions from these softwares. Okay, and it runs on Linux, Unix, Mac OS, and Windows. So any operating system you are on, you can use QGIS. If you're using a MacBook, you can install QGIS. If you're using Windows, Linux, etc. Anywhere QGIS will work. What about GRASS? GRASS is one of the oldest softwares. The story goes like it was developed by the US Army, and then it was open sourced in the year 1984. And since then, it has been under constant development. It is under constant development, and it is one of the oldest and most powerful softwares. The problem with the difference between QGIS and GRASS is the QGIS has become very popular, whereas GRASS is not. Why? Because GRASS till a decade back was primarily a CUI based, a character based interface. So you had to type commands to do stuff, and there were no buttons where you could click on. But recently they've come up with a nice GUI, and also I have read somewhere they are going to improve the GUI and make it even more user friendly. So, but it is very powerful. It has raster, vector, geoprocessing engines, and it has a lot of tools for spatial modeling, visualization, management and analysis of geospatial data, processing of satellite and aerial image, temporal framework for advanced time series processing, and also Python API for programming. QGIS also has a Python API. And GrassGIS has been optimized for performance of large geospatial data analysis. When you have large amounts of data, GRASS has been optimized to work with all that. Now, this slide basically shows all the advanced functionalities of QGIS. So on the left side, you are seeing a 3D visualization of the buildings in Manhattan, New York states. And here the buildings are shown by their height. On the top right, you see a visualization of the number of COVID cases which happened in the state of Uttar Pradesh during April to October in 2020 in India. And these polygons show individual districts. The blue color shows less number of cases, less than 10. Then comes yellow, and then comes the red, which is more than 20,000 cases per day. So this is how the disease spread. And as you can see, it started with the urban centers like Noida, Kanpur, and Lucknow, and then it spread throughout the entire state. So this kind of space-time visualization of data is also possible in QGIS. Now they are coming up with a new functionality called mesh layers. This can be used for things like flood routing and overland water flow and so on. So this mesh layer support will add new features and give more power to QGIS. If we talk about libraries, there are different libraries available for GIS work. But GDAL is the most popular one. If you have any experience with programming, you will come across this library once you think of writing code to process your remote sensing GIS data. GDAL is the most popular library, which basically provides an API to read and write raster and vector data. You read raster data, you do some process, and then you write your output. Same way for vector. PostGIS is also a very popular open source database management system. Sorry, PostGIS is the extension to PostgreSQL, which is the most popular, which is one of the most popular open source data management system, and it allows storing data, raster data, vector data into a database, and then fire what are known as ST queries, that is space-time queries, to do your spatial analysis on the database itself. If you are thinking about doing some web-based maps, something like Google Maps or Bhuvan and things like that, you will need to know this software called GeoServer. This allows to serve maps in different formats on web browsers. So you can create some data and publish it through GeoServer. Anybody with an internet connection can connect to your URL and then view the data in their browser. It can also be used to do advanced things like WFS, Web Feature Service, where you can actually transfer the vector data over the internet and stream it. Then there is a library called OpenLayers. OpenLayers and Leaflet. There are two libraries which are very popular to make these nice web-based maps which use HTML5 and CSS and WebGL to make it very nice, smooth animations, zooming in and zooming out and panning and all that can be done using OpenLayers and Leaflet. These are all JavaScript libraries which are made for modern browsers. Next, I want to tell you about a topic called FOSS-based data collection, free and open source software for data collection. Now, what happens, a lot of you, as I understand, are do a lot of field work. You need to go to the field, you need to collect data. How do you collect the data? You take a notepad and a pen, take a GPS receiver, go to the feature of interest, note down the latitude, longitude, some details about it, go to the next point, and so on. And you continue collecting the data, then you come back to your lab or to your office, and then you enter that data into an Excel sheet or into your software. And many times what happens is, from the time you've collected the data to the time you've entered, there may be some time gap. You've forgotten some details get misinterpreted. Maybe you've spilled coffee on some pages. So these things are human. These things happen. The data gets lost from the point it is collected till the time it is interpreted. It gets changed. It gets mismanaged. What can we do to avoid this? Can we have a device or can we have a system where we can collect data automatically on the field and it immediately goes into the computer and there is no manual process in between? Now, to do that, you start off simply the traditional way. You list out what things you need to collect, like the location, text data, numeric data, date, time, maybe a picture of the place, maybe some video clip or an audio clip, and then uploads this form to a specific software called Aggregate. Okay. Then the surveyor who is in the field, he will install ODK Collect and then download that form from Aggregate. And then he will collect the data in the field. And in real time, the data gets uploaded on the server, where the officer who has proper authentication can view the data, can visualize it, can export it, and create spatial data out of it. If the guy who is doing the survey is in an area where there's no network, still he can collect the data, and as soon as he comes to the place where there is network, the data automatically gets uploaded to the server. So that thing, I am going to a place where there's no network, will I be able to collect data through my phone? Yes, you will be able to do. And these applications are very smooth, intuitive, and you can create nice applications. So for example, you can collect a lot of data through a lot of ways. You can ask the user to select any one of these options, or you can ask the user to type something, a numeric value or a text value. You can ask him to check certain boxes, or you can ask the user to take, or the data collector to take a location, an image, barcode, even an audio video clip, anything. All this data gets, as I said, gets uploaded to the server in real time. And you can see this like a table shown here. So there are images, there is latitude, longitude, time when it was taken, and different other characteristics which were captured. All this data can be visualized on a map or as bar graphs and pie charts, etc. Now, the most popular app these days is GeoODK, but IIRS has developed an own app called Q Real Time, which is a great app to do field-based data collection. Other apps like Input App and some others are also quite popular. Where could I use this app? Where could you use this technology for collecting data from the field electronically? It is very useful for completing surveys about households, something like census surveys and stuff like that. For crisis mapping, to capture images and locations of damaged areas. For collecting different types of multimedia data, you want to collect audio or video from the field. So there you could use it. For baseline surveys, for project evaluation, etc. One of the biggest success stories of using this product or using this technology is a project called Map the Neighborhood in Uttarakhand, or in short, MANU. This was used to assess the damage post the Kedarnath disaster, which happened in 2013. As some of you may know, there was a very large flash flood in 2013, and on these pilgrimage sites where there were a lot of people and a lot of people lost their lives, and there was huge loss to property, a lot of roads and bridges were washed off, and things like that. So we took help from 4 universities in the state, and a lot of students were then sent to the field where they used these apps to collect data on the field. You can see these blue pins here, which basically show all the points that were collected on the field. So, for example, the damage to buildings, there were about 1,000 points collected in these red points. Damage to roads, the number of points were around 500. And then damage to bridges, about 50 bridges were damaged. And for each point, if you click on them on this web interface, you can see a photograph and different attributes of the data set. This data was then further analyzed to find out the most affected disaster areas, which could later be used for focused disaster management purposes. Other success stories include geotagging of post offices in India. The India Post, the guys who deliver the post in India, there's a huge network. It is a huge infrastructure, and there are so many post offices that you wouldn't know because they're really small and they're inside these buildings. So now they wanted to create a web interface where the locations of all their post offices should be known. What are the services each post office offers? So ISRO gave a solution which used these applications, mobile-based data collection, where the postmasters themselves could geotag the post office. They could post a picture along with what services are available, along with the contact details and the location of that post office. And all this is available on a single web page. Any user can simply put in a zip code or pin code and find out what are the nearest post offices to him. This is also heavily used for the watershed monitoring programming in India, where large amounts of funds are being released, government funds are being released to monitor the, to do watershed level development, and to detect or to monitor this expenditure, whether it is being used correctly or not. These apps are being heavily used. So these are some success stories from these data collection apps. Finally, I would like to tell about some of the misconceptions that are there around using open source softwares. Some people say that it is not suitable for cartography. That the outputs that they will make, like the maps and all, are not accepted in journals or thesis. This is completely false. This is not true. And I can tell you from my personal experience that all big journals take papers with maps made using open source softwares, and they happily accept it. And there is no such, this is a complete false thing. Some people say that there's no support, it's not safe, and it is not stable. It may stop working any day. Your maps or data may become open because you're using open source, and it is prone to vandalism because since it is open source, so anybody can break it. It is not that. All these again claims are all false and lies. There's a lot of support available. The support is not free. The software is free, but there are certain companies, I know a lot of them in India and in the States, but which offer support for these open source software. So if you are facing some problems, or you want some trainings, or you want certain functionality to be developed, there are people to help you out there. But that costs money. That doesn't come for free. The software itself comes for free. It is not safe. This is quite the opposite what open source is. It is much safer than closed source softwares which are doing unknown things without telling you. Okay, so for example, you're using some software on your mobile phone, and it is in turn sending your private data to its own servers without telling you. Okay, and that is the case in a lot of apps. I don't want to take their names, but you probably have guessed that there are a lot of apps which you're giving your personal information and they are using for targeted ads. So basically they are taking your data. And so which one is safe? The ones, so open source are better. They are safe. They don't take your data. It doesn't go anywhere. It's very stable. Open source is not made for professionals, made in basements and garages, and requires programming knowledge. It is not so. It is it is made by professionals, but it is not made only for professionals. Any beginner, anybody with no programming knowledge can use it, and it is very easy to use. Outputs will not open in other software. This is quite opposite to what happens in closed source. Closed source softwares have this game where they give the outputs in a format which opens only in their software and not in any other. That is called file format lock-in. And they've been playing this game for a very long time. And they say, no, this format is best and all that. But it is not so. There are open formats given by standard organizations like ISO, but they're not following that, and they say, no, we have our own format which is even better. So that is not true. Open source software, all the outputs will again open in other softwares also, and so on. So these are different types of lies that people tell about open source. These are not true. You should not listen to them, and please use and decide for yourself which one is good. So I'd like to stop here today. I would be more happier to discuss things which you have in your mind regarding softwares, open source softwares or closed source softwares. And so I look forward to your questions in the chat boxes. And